Hi everybody. So this little video is going to help us with nomenclature. So we're getting into this process now where you need to be able to recognize if I give you a name of a substance, what that formula would look like and vice versa. And so this whole idea is based on something called nomenclature. The idea of nomenclature, or the word nomenclature, I guess, really is all about naming things. Naming substances. So it's a special set of rules, classifications that will go through and help you be able to name whatever types of things you're coming across. So for us, we're going to start out with monatomic ions, and then we're going to build into how do we put these ions together to make ionic compounds. And then from there, we're going to learn about another type of compound, our molecular compounds. So first things first, let's just start simple with our monatomic ions. So you see the prefix mono. What does that mean to you? Hopefully it means one. And then you see the word atomic and you're like, okay, well, hopefully that's talking about atoms. It is. And then ions, a charged atom. So a monatomic ion is a one atom ion. And you might be thinking, Miss Lambert, a one atom ion, could there be a more than one atom ion? Oh, spoiler alert, yes there is, and you're going to learn about those later. So for right now, we're focusing on monatomic ions. So there's two types of ions we know about, cations and anions, and they have two different rules for how you're going to name them. So we're going to start with cations first because those ones are easy peasy. So if you wanted to name a cation, let's say calcium. The first thing you have to ask yourself is calcium a metal or a non-metal? Well, we know that calcium's a metal, which means it's going to form a cation, so we're going to follow this set of rules. So if I gave you this and asked you to name it, you would look and say, hey, that's calcium, that's its identity. I know it's an ion because it's got the charge in there. I know it's a cation, so how do I name it? Well, according to this set of rules. The rule is it has its elemental name plus the word ion. Super easy. So it's just calcium ion. So real quick, see if you can get this one. This is the strontium ion. If I give you this, what's its name? Just strontium. Since there's no charge on there, now it's just the element name. So be careful with these. So we also learned that there are some metals, some cations that can experience multiple charges. And I gave you the little table of them on this next page of your notes packet. This is the table that you saw in the last unit. So anything that's highlighted in this periwinkle color can experience multiple charges when it ionizes, which means that it's possible for them to lose a different amount of electrons, not always a set amount. So if anything shows up that's blocked off in this periwinkle color, it can experience multiple charges. So think back to when we were naming isotopes. Remember when we named isotopes and you had to identify the isotope by its mass number to tell people which version of the element you were talking about? It's the exact same thing with ions. Ions that can experience multiple charges, you have to tell people which charge it actually is. These ones right in here, silver, cadmium, zinc, these are transition metals that are not able to experience multiple charge. I expect you to have these memorized. So silver's +1, zinc's +2, cadmium's +2. If you need to, put them in your personal periodic table. Okay, so how do we name these things? Well, if a cation can experience multiple charges, what we're going to make use of is Roman numerals. So if you don't know your Roman numerals, here you go. You need to be able to count to 7. Whew, I know. Kindergarten. 1, 2, 3, 4, 5, 6, 7. There you go. Just a set of V's and I's. Every I represents 1. V represents 5. So something like 4 would be 1 before 5. So therefore 4. That's how they count. So give yourself that little cheat sheet so you know your Roman numerals. So let's say we were talking about copper. So copper has two forms to it, two ion forms. It could be Cu1+ or Cu2+. So to tell people which version you're talking about, you use a Roman numeral, and the Roman numeral represents that charge. So here, In Cu2+, its charge is 2+. So how do we say that? We call it copper 2 ion. So same rule, because it's a cation, you keep its elemental name and the word ion at the end, but you just add in the Roman numerals to tell people the charge. So how would you describe this ion? How would you name it? Copper 1 ion. Exactly. Okay, so then we've got anions. So here in an anion, this one's just a little bit different. So let's say I gave you this ion right here, F minus. Well, what element does F represent? Fluorine. Fluorine is a nonmetal and therefore will gain electrons to form an anion. So how do you name it? Well, you start with the elemental name, fluorine. You drop the ending of the elemental name and you add the suffix "ide," I-D-E. And since this is an ion, you have to add the word ion at the end. So fluorine would become fluoride ion. Kind of the general rule is it's going to be between the last 3 to 5 letters of the element name that you drop. It really does kind of depend. I've typically found that it's you go up until you hit a vowel. So like us, we hit this I vowel here, and that's going to be what you drop. But honestly, this just comes with practice. And so we're going to practice these a lot in class together. Okay, so let me show you how you can go all the way through giving just the neutral element name to getting the ion name. This is the long, extensive, drawn-out process, but eventually you'll be able to just do this. If I give you just the formula or the name, you can quickly go back and forth. So I have an example of sulfur there for you. I'm going to do magnesium with you, and I will do chlorine with you, and then the rest I'm going to leave you to do as practice and then check the answer key. So start off with magnesium. Is this thing a metal or a nonmetal? It is definitely a metal. Now you got to determine how many valence electrons it has. This thing's got 2 valence electrons. So because it's a metal, is it going to gain or lose? Well, it's definitely going to lose. It's got less than 4 valence electrons, so it's easier to lose than it is to gain. So we're going to lose these, and how many? Well, we're going to lose until we're stable. That's the whole point of ionizing, right? We want to have a filled valence shell. So I'm going to lose all 2 of those valence electrons. When I do that, what's my charge going to be? Well, I lost 2 things that are negative, so now I've got more protons in the nucleus than electrons in the surrounding the nucleus, so I've got to have more positive charge than negative. How much more? 2 more. Also, it's a metal, so check yourself. You know it's got to be a cation. Now you put it together for the chemical formula. So the symbol for magnesium is Mg, and its charge is 2+ when it ionizes, so this is the symbol. How do we name it? Well, this thing is a cation, and so because this is a cation, I want to name it according to my cation rules. It is not in that periwinkle group. It's not a transition metal, it's not a post-transition metal, it's just a cute little S block, a little alkaline earth metal. So I just go according to the top rules. I keep its elemental name, add the word ion. Magnesium ion. Woo, easy. Okay, one more. All right, now we got chlorine. So think to yourself, metal or non-metal? Non-metal. How many valence electrons? 7. Is this thing going to gain or lose? Definitely gain. It's super close to filling that valence shell. How many will it gain? 1, because then I've got an octet. What's the charge going to be? It's going to be 1 minus. I gained 1 electron. What's its chemical formula? Well, chlorine is Cl. And now I have a 1 minus charge. Remember, you can just put the minus sign if it's in 1. It's invisible in there. It's implied. How do I name it? Well, this thing is an anion, so now I got to go according to my anion rules. Check back here. If I have an anion, I keep the elemental name. I drop the ending and add "ide," put the word ion. So chlorine, I'm going to drop the "ine," and I'm going to add the "ide" to make it chloride ion. Perfect. So this is your monatomic ions naming rules. Go ahead and practice the rest of these ones on this page. Check in with the answer keys. See how you do.